All right, hello, my wonderful students. This is foldable number 2, section 2.5, Piecewise Functions. And I'm actually going to do the work on a separate sheet of paper, which I printed out, which is here. But I kind of want you guys to follow along, and I'm going to give you printouts, which are going to be glue and do's. So I'm going to kind of, we're going to do them, and then we're going to glue them in our foldables after. All right, so for this one, I kind of drew the parent function for the top function already. So we're going to ignore the bottom function for now. We're just going to pretend that we're going to do the top function, and we'll do the bottom function after. All right, so for this one here, we already know that what our function is. We have that our function is a parabola because we have the squared here. And we know that this transfers 2 units to the left because it's positive 2 there. Whenever we have a number affecting the x inside the parentheses squared, then we know it's going to be the opposite direction of what it is. And if we have anything on the outside, it's going to be true to its value, but we don't on this one. Okay, so we're going to go ahead and transfer this function over. So we know it's moving over 2 units to the left. So we're going to start here. So go 1, 2. Let's do it in a different color. Let's do it in blue. We go 1, 2, 1, 2, 1, 2, and 1, 2. And we can go ahead and draw our transferred parabola. And that's the one we have here. All right, but we have something very important. We have a restriction in our domain, which is x is less than -1. So we're going to go to our -1. Sorry about doing the parent function and this one in red, but I'm also going to do this one in red here. All the way down to the bottom. So this function only exists when x is less than, not less than or equal to, less than -1. So x is less than -1 here. So that means this function only exists here. From this side. And it does not exist on this side because of this restriction here. But we also see this is just less than. That means this is going to be an open circle because it's going to be open-ended because it's not equal to, it's just less than. If it was less than or equal to, or for this case, greater than or equal to, then it would be a closed circle on that one right there. So we're going to go ahead and draw this one as well. This one is a constant at 2. So this is y is equal to 2, and y is here, and y is equal to 2 is actually on this line here, on the number line 2. But the y is, this y equals 2 only exists when x is greater than or equal to -1. So on the same line here, but it's actually right here. And this one is going to be a closed circle because it's x is greater than or equal to. Very important. And we're just going to draw the line straight across here. And this goes on forever as well. So our actual graph is just this part here, jumps, and then this part here. So this graph is discontinuous, or has discontinuity as well. And the left side goes to as x approaches -infinity, y approaches positive infinity, and this one is just x goes to positive infinity at a constant rate. All right, so therefore, actually no, we don't have to do that. So therefore, but I do want you, like when you flip it over, I do want you guys to write that this is a quadratic linear piecewise function. Remember, this is going to go on the flip side.